In this video, we're going to take a look at energy level diagrams and Bohr level diagrams. In order to do this, we're going to need to reference our periodic table. And there are a few things that are on the periodic table that you need to understand in order for this to work. You have orbitals that occur, and they are following the periods. Periods go horizontally across the periodic table. So this is our first orbital, second orbital, and third orbital. We won't ask for any of these diagrams that go past 20, and probably will be mostly focused on up to 18. Hydrogen atom has got one proton. So the hydrogen atom has one proton because its atomic number is 1. So a hydrogen atom has one proton and it has one electron in the first orbital. So it's got an orbital that goes around it. And the electrons are going to be drawn with an X or a dot. So we could put a dot like that, or we can use an X. So a hydrogen atom would look like this. Sometimes you'll see there's a circle around the proton. That's just referencing like the nucleus of the atom. Carbon atom has 6 protons, and I know that because its number is 6. It has, here, let's just quickly clear this a little bit. And so carbon has got two electrons in the first orbital, and I'm going to show that like this. So its first energy level or orbital is full, and then carbon has 1, 2, 3, 4 more electrons in the next energy level. So we draw another circle around it, and we put 1, 2, 3, 4, and that's the Bohr diagram for a carbon atom. If I wanted to draw the energy level diagram, for a hydrogen, it has 1 proton and 1 electron in its first energy level, and then for carbon, it has 6 protons, it has 2 electrons in its first energy level, so that's here, and then in the second energy level, it's got 4 more. So it's got 4 electrons. Now the outer orbital is called the valence shell or valence orbital, and the inner orbitals are just called inner orbitals. And we're not usually as worried about the inner orbitals because the valence shell is where the bonding happens. So if we were to do nitrogen, nitrogen has 7 protons. Its atomic number is 7. It has 2 electrons in the first orbital. It's got 5 in the next. And the reason that I'm showing nitrogen is because when I'm loading up this, I get the 2 on the inner orbital, it fills, and then I've got 4, and that's when I can start making pairs. If you did it like this, so if you said, oh, nitrogen has got 5, 1, 2, 3, 4, 5, that would be the incorrect way to populate this. This would be a wrong Bohr diagram. Sorry. What we would end up getting, so what we need to do is for a nitrogen atom, I'm going to have those 7 protons, and I need to fill up the 4 sides of this before I start making pairs. So my energy level diagram has 7 protons, 2 electrons on the inner shell, and 5 electrons in the valence shell. Fluorine atom is going to have 9 protons. It'll have 2, then 1, 2, 3, 4, 5, 6, 7 in the outer shell. Now, if we looked at the periodic table, you'll see that fluorine is in group 17. The atoms that are in group 17 have 7 electrons in their valence shell. In group 16, they have 6. So there's another little hint for you, right? Nitrogen is 5, carbons would have 4, boron would have 3, and if we go over to the other side, hydrogens will have 1 and beryllium will have 2. We won't be asking about these chemicals and energy level diagrams or Bohr diagrams. First of all, they get way too big, and second of all, they're transition metals, so it doesn't work as well. Neon is important because it is a noble gas, so it's got the 2 electrons, and then it's got 1, 2, 3, 4, 5, 6, 7, 8. And so it's got a complete octet or a complete valence shell. The fact that it has this complete valence shell makes it extremely stable and unreactive. If we went forward to the magnesium atom, which has got 12 protons, it'll have those 2. It'll have 2. Then it'll have, the next shell be full. It'll have 1, 2, 3, 4, 5, 6, 7, 8. And then in the next shell, it's got 2 more. But remember, we have to fill up the 4 sides of the shell before we start making pairs. So it'll have 1, 2. One of the things people ask me is, do I have to put them in that order? Like, does it need to start at the top and go to the side? The answer is no. If it's got 2, I can do it like this, or I could put them like this. It doesn't matter. I just can't start making pairs until I have completed that. So sulfur atom has got 16 protons. It's going to have 2 electrons, 8 electrons, and that gets us to 10. So in the next orbital, the valence orbital for sulfur, 1, 2, 3, 4, 5, 6. So that's how you build Bohr diagrams, and the energy level diagram for sulfur would have 16 protons. It has 2 electrons in the first energy level, 8 in the next, and 6 electrons in its valence orbital.